All right, we'll go over this page really quick. I did definitely learn something new about, well, I knew this was like the summation notation because we use that in stats a lot. So if you just want to go from 1 to 5 and you're taking everything to the third power, it just means you add up 1 cubed plus 2 cubed, etc. I did not know you could do this in your calculator, so it's just kind of something cool to know. If you hit the math button and then you scroll down to number 0, summation, and then it looks like this. Make this a little bit. So we could say, you don't want to put I in, but just like put in the letter X there. So X equals 1, and then up to 5, and then instead of I squared, or I cubed, I wrote X cubed. Like that. And then when you hit enter, it gives you the answer. So I thought that was kind of cool, just some interesting things. You can just, there you go. You can just kind of look over my notes and write these in, but we're not going to really spend too much time on page 1. All right, page 2 and 3. I'm kind of mad that I used that orange pen and it shows through, but if you watched any of the videos, they kind of explain this, approximating the area under a curve, and we can do that by making rectangles. And can you guys tell this is going to definitely be an overestimate because these rectangles are accumulating more area than just underneath the curve. And we're going to talk about this a little bit more on the next page. Here's the general rule, which the video that I wanted you guys to watch is kind of, I think, an older lady that was doing it. I thought she did an excellent job of describing where this formula comes from. So if you just want to watch that, and I just said just watch the first like 3 minutes of it, I think she does a great job of explaining this and talking about overestimate. Page 3 in your notes, this would be an example of a left endpoint. So the endpoints are on the left side of the rectangle, and you guys can clearly see this would end up being an underestimate because the rectangles are accumulating less area than the curve. So again, that's kind of explained in the video that I posted about the one that I said just watch for 3 minutes. Here's page 4. You don't have to do anything or calculate anything on page 4, but it just gets you thinking, and you can kind of clearly see the skinnier your rectangles get, the more accurate a description of the area under the curve we're going to get. Here the change in X, all the rectangles are 1 unit apart. Here they're all half a unit apart. What would happen if they were all just 1/10 of a unit apart? And then that kind of like leads in this formula that we talked about on pages 2 and 3. What I want to spend the most time